Today's AI is an absolute master of language. I mean, it can write poetry, it can debug code, summarize these incredibly complex documents in just seconds. But it's got this one huge and honestly kind of fascinating blind spot. It can't really see the world. And that single limitation, well, that's the key to its next giant leap forward. This quote from the legendary AI pioneer Dr. Fei-Fei Li, I mean, it just hits the nail on the head, right? For all the stuff it knows, AI doesn't have that deep, intuitive feel for our physical reality. It's kind of like this brilliant mind that's read every book in the library, but has never actually stepped out and felt the rain. Okay, so check this out, because this really breaks it down. A large language model can explain the physics of gravity perfectly, right down to the last decimal. But it doesn't get it. It doesn't understand the simple real-world experience of just dropping a ball and watching it bounce. That's its physical blind spot. It just doesn't grasp concepts like object permanence, the idea that something still exists even when you can't see it, or weight, or simple cause and effect in a 3D space. So, this all leads to the big question, the one that's driving this entire next revolution in artificial intelligence. What would it take for AI to go beyond just words and develop what all these researchers are calling spatial intelligence, a true, grounded understanding of our physical world? Well, the answer to that question is a totally new class of AI called world models. These systems are being designed not just to process language, but to actually understand and even simulate our physical reality. We're talking about a jump from words to worlds. So what exactly is a world model? Well, think about it like this. Instead of trying to predict the next word in a sentence, a world model learns the basic rules of a world, things like gravity or how light bounces off surfaces, so it can predict what happens next. It's literally building a mental model, a little simulation of an environment that it can then reason about. And look, this didn't just pop up out of nowhere. This timeline shows how AI has been on this steady march toward understanding our reality. We started with models that only knew text. Then we got systems like Clip that could connect images to words. More recently, we've had AI that can describe what's happening in a video. And now, with world models, we're taking that final leap to a real, grounded understanding of space and time. So, here's the deal. A real-world model, it's got to do three key things. First, it has to be generative, meaning it can create realistic 3D worlds from basically nothing. Second, it has to be multimodal, so it can understand all kinds of inputs, text, images, video, you name it. And finally, and this is crucial, it has to be interactive. It needs to be able to predict how the world will change if you take an action. Okay, so how is this stuff actually being built? This is where it gets really interesting. Because right now, we're seeing this fascinating battle play out between these smaller, scrappy, open-source challengers and the massive proprietary models from the big tech giants. Now, this is what I find fascinating. Take a look at this showdown. You've got Molmo 2, which is a pretty small open-source model, but it's actually beating Google's gigantic Gemini 3 Pro on really specific spatial tasks, like tracking an object in a video. And that's because it was built from the ground up to connect its knowledge to visual data. Now, Gemini still wins on broad academic-style reasoning, but this just shows that specialization really matters here. And this isn't just some theory stuck in a research paper. No way. A company called World Labs has actually released a tool called Marble, and it gives us a real, tangible peek at what a world model can do for, well, all of us. Okay, the way this works is just mind-blowing. You can give Marble a single photo, like of your office, or even just a simple text description. It uses these really advanced techniques like neural radiance fields and Gaussian splatting, and it spits out a complete, interactive 3D space that you can literally walk around in and even start moving things. It's incredible. All right, so this is where we get to the so what part. Because once AI gets a handle on physical space, it can start helping us in ways that honestly used to be pure science fiction. This is where spatial intelligence is going to change, well, pretty much everything. I want you to just picture this for a second. AR-guided repair. A technician puts on a pair of smart glasses. The AI instantly identifies the machine in front of them and all its parts. Then, a digital arrow pops up, pointing directly to the broken component. The system gives step-by-step instructions, and here's the amazing part. If the technician reaches for the wrong wrench, the AI sees it and flags the mistake in real time. And get this isn't some far-off prediction. Companies like Airbus are already rolling out early versions of this tech, and they're reporting a stunning 40% reduction in the average time it takes to do repairs. That is a massive, massive gain in efficiency, all because AI finally has spatial awareness. And really, the possibilities are they're everywhere. We're talking about surgical AI that can help a doctor during an operation. We're talking about factory robots that can predict where a human is going to move so they can work together safely. Architects who can walk through a building moments after sketching it out, even creating entire digital copies of cities to manage traffic flow in real time. Okay, so where do we go from here? Let's talk about the road to 2030, the hardware that's going to bring this to all of us, the major hurdles we still have to get over, and what's just around the corner. First up, the hardware. And look, it is coming, and it's coming fast. As you can see from this roadmap, all the big players, Google, Meta, Apple, they are all gearing up to release advanced AR glasses between 2026 and 2027. These are the devices that are going to put a world model literally right in front of your eyes. But it's not all smooth sailing. There are some huge, real-world roadblocks we need to talk about. The amount of power these models consume and the data center space needed to train and run them, it's just enormous. The truth is, if AI doesn't get a whole lot more efficient, these physical limits could actually start to slow down progress. And then there's this, a massive challenge for all of us. Some projections are suggesting that by 2030, almost 3/4 of everything on the internet could be generated by AI. This idea of a synthetic web brings up some really big questions about truth, about authenticity, and about how we're going to tell what's real from what's a simulation. So, after all that, what's the big takeaway? What does this all boil down to? It's that we are standing right on the edge of a completely new relationship between artificial intelligence and our physical reality. Look, the change we're talking about here, it's absolutely monumental. This is the moment AI stops being just a statistical machine that only understands data and starts becoming a true partner that can see, reason about, and interact with the world just like we do. I really think 2025 is going to be remembered as the year AI finally opened its eyes. And that leaves us with one last big question to think about. For all of human history, we've been the ones shaping our world. Now that AI can finally understand our physical reality, how is it going to start reshaping it for us?